In this lesson, we're going to find oblique or slant asymptotes of a rational function. In this example, we're asked to give the equation of any horizontal or oblique asymptotes for the graph of the rational function. So looking at the degree of the numerator, it has a degree of 2. The bottom has a degree of 1. And since the numerator, the degree of the numerator is greater than the degree of the denominator, recall that in this case, there is no asymptote. Now, just because there is not a horizontal asymptote doesn't mean that we don't have other asymptotes. So there could be an oblique asymptote if the top is 1 degree higher than the bottom, and that is the case here. So again, the guidelines are if n, the degree of the numerator, is exactly 1 more degree than the denominator, then there will be an oblique or slanted asymptote. And to find this oblique asymptote, all we have to do is to divide the rational expression, top polynomial divided by the bottom. The quotient, our answer of that, is the oblique equation of the asymptote. Now, if there are any remainders, you must disregard the remainder. So let's go ahead and divide this. We're going to divide this using synthetic division, and notice it goes from degree 2 to the constant. We are missing degree 1, so we need to put in a placeholder of a 0 for the first degree. And then also on the bottom, notice our divisor is going to be 2. So let's go ahead and set up our synthetic division. I'm going to begin the process by bringing down a 1. Multiply that with 2 to get 2. Bring down 2. Multiply that with 2 to get 4. Bring down a 5. Here we have a 5 remainder, and recall that you have to disregard the remainder. So once we do that and write our polynomial, remember we're going to write it as 1 degree lower than the original polynomial. This polynomial begins with degree 2, so we're going to begin our answer with degree 1. So that will be x plus 2 will be the equation of the oblique asymptote. In this example, we're asked to give the equation of any horizontal or oblique asymptotes for the graph of the rational function given. So let's take a look at the degree of the numerator is 2. The degree of the denominator is 1. Recall, when the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. However, there is an oblique asymptote because the guidelines for an oblique asymptote is if the degree of the numerator is exactly 1 more than the denominator, then there will be an oblique or slanted asymptote. Now, to find this slanted asymptote, all we have to do is divide the polynomial, the top divided by the bottom there. So let's go ahead and do that using synthetic division. And by the way, any remainder that you may have, you just disregard the remainder. So notice our outside number is going to be 3 for our divisor. So let's go ahead and plug everything in and get set up for our synthetic division. All right, so here we go. We're not missing any terms up top, so we don't need to put any placeholders. It is what you see here, which is a coefficient of 1, -4, and -5 for the top polynomial. All right, let's begin by bringing down a 1. Multiply that with 3 to get 3. Bring down a -1. Multiply that with 3 to get -3. Bring down a -8, and again we're going to disregard our remainder of 8. We're going to go ahead and plug in our variables. So that means that the equation for our slanted asymptote is the line y equals x minus 1. And there you have it, oblique asymptotes. In this example, we're asked to determine the horizontal or oblique asymptote, if any, for the rational function given without using a graphing tool. Okay, so here, let's take a look at our degrees of both the top and the bottom. The degree of that polynomial is a degree of 2. The bottom polynomial has a degree of 1. And recall, whenever the degree of the numerator is greater than the degree of the denominator, that there will be no horizontal asymptote. So we can cancel choice E because there is no horizontal asymptote. But just because there's not a horizontal doesn't mean you don't have an asymptote. This fits the guidelines for an oblique or slanted asymptote, which is when the degree of the numerator is 1 more than that of the denominator, then there's an oblique or slanted asymptote, and to find it, all you have to do is divide the polynomial, top divided by the bottom. So let's go ahead and do that using synthetic division. So we're going to have a -2 on the outside, and our coefficients underneath our division symbol is going to be 1, -7, and 3. Let's begin that division process by bringing down the 1, multiply that with -2 to get -2. Bring down -9, multiply that with -2 to get 18. I'm going to bring down 21. In either case, we always disregard the remainder. And what we have here, when we put in our variables, our line of our oblique equation is going to be y equals x minus 9, which is, as you can see, choice A. So how did you do? I'm sure you did well.
Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.